Okay. If you can see that screen, again, it says bell work at the top. Can you give me a thumbs up? Awesome. Okay, we're good to roll. So our first one is my favorite trigonometry joke of all time. This is a real student answer that a teacher posted. Find x. Here it is. How can you do anything but give that student full points for finding x? They did it. Nice job. Well done. But we're going to need to do a little better than that. So we're looking at trigonometry of right angles. Again, this is something you will have seen in grade 10. Pretty much everything we're going to cover today in this first lesson will be stuff that you saw in some form or another in 10th grade. So much of it will seem familiar. Some of it you may have forgotten. Some of it you may have never learned in the first place because last year was weird. But the hope is that a lot of this has sunk in and is still in there. And if not, hey, it's something new to learn, and that's cool too. Okay. So when we're talking about trigonometry, the name actually, what we're doing is actually right there in the name. So tri, of course, means 3, gono is angle, and metry is measure. So we're just doing 3 angle measures. And that's what trigonometry is all about. It's right there in the name. Of course, Pythagorean theorem is the one you learned in grade 9. And Pythagorean theorem is that beautiful theory that was discovered by a whole bunch of different cultures in the Greek culture, in Arabic culture, in Mayan culture. There's a whole bunch of different cultures that discovered this mathematical idea. And that's, of course, that our hypotenuse, which I'm just going to label, I'm just going to call my hypotenuse C, and I'll call the other sides A and B. I can call them whatever I want, but I'm gonna call them that. You'll also notice I've labeled them with lowercase letters. Lowercase letters are the ones we use for sides. Uppercase letters are what we use for angles. And I'm actually going to label the angles too, just because that's kind of good to get in that practice. So angle A is going to go right here, and across from angle A, I see side A. So angle B is going to go right here, and across from angle B, I see side B, and that means angle C is the 90-degree one right here, and across from angle C is side C. So I always have my angle matched up with the opposite side using the same lettering. Angles are capitals, sides are smalls. Okay? So for Pythagorean theorem, we remember that we say, okay, the two smaller sides, that would be A and B. If I add those together when they're squared, so times themselves, they're going to be equal to that long hypotenuse side squared. I could also write this another way. I could say the hypotenuse side, which is bigger, is equal to the other two sides squared. So that's my reminder to grade 9, my Pythagorean theorem. We can use that anytime we've got a right angle triangle with that 90-degree angle in it. I, of course, want to warn you that triangles will not always be labeled with side C as the hypotenuse. They could be labeled with any letters. So we just got to remember that our hypotenuse squared is the other two sides squared. So let's try this. I'm going to do one really quick, and then I'm going to want you to do the other one on scratch paper. If you're feeling pretty comfortable, you can jump in right away and go for it. But often in these ones, I'll do one, and then I'll show you one, and then I'll ask you to try one. Okay, so have your paper handy, and if you're feeling good about it, you can jump in right away and go for it. I'm going to start here, and I'm going to do my first one. So I'm going to say, okay, I know that my hypotenuse side, in this case, it's labeled as x. If I square that, it's going to be equal to my other two sides squared and added together. And I recall that, I might need a calculator for some of these. I happen to remember that 12 squared is 144. And I know that 5 squared, 5 times itself, is 25. And now, using my proper order of operations, I can add those two together because I've already done the exponents. So I'm going to go 144 plus 25, that's 169. And now to get x by itself, I need to take the square root of both sides. So I'll take the square root of the left side, and then I'm going to take the square root of the right side, 169. Now I have to do the square root of 169 in my calculator. Turns out that's 13. There's a catch, though. It could be positive 13 or negative 13. So I'm actually going to put plus or minus 13 to start, because I don't actually know if it's positive or negative. And you might say, hey, Mr. Roy, we know it's positive because it's on a triangle. What would negative 13 of that side even be? And you're right if you say that. So that's got to be positive. We're going to say must be positive. I'll use a plus and then a VE to represent positive. So that's got to be the positive one, because negative 13 wouldn't make sense in this case. Okay, I'm going to ask you right now to try the second one if you haven't started it on it already. And our solution for our second one, it should come out to be 4. So I'd like you to try that out to make sure that you can get to 4. Now, doing the second one, you would have said, if you're already there, that's great. If not, that's okay. You would have said, aha, the hypotenuse is going to be 5. So I'm going to write the two other sides, y squared and 3 squared on this side. And I'm going to put my 5 squared over here. So that's going to be y squared plus 9 equals 25. Y squared, I'm going to subtract 9 from both sides. And so I'm going to end up with y squared equals 16. And then I got to take the square root of both sides. There's also a little trick with this. If you've got a right angle triangle and you know 2 of the sides, and they are either a 3, a 4, or a 5, some combination of those 2 numbers, the other side must be the third one. A 3, 4, 5 triangle is a really common triangle. Carpenters actually use 3, 4, 5 triangles in order to square up the sides of buildings when they're building them. They just pull out their tape measure and measure off 3 feet, 4 feet, and 5 feet. And so if you've got those 3 measurements, they have to make a right angle triangle. So this is actually used in the skilled trades quite commonly with a tape measure, just to square things up in a really easy and fast way. So 3, 4, 5 triangle is a common thing. Okay, so Pythagorean theorem. Xavier, hi. Thanks for letting me know. I'm glad you're here. I'd like you just to throw in the chat really quick how comfortable you're feeling out of 5 with, don't do it just yet because I'm going to type in a new one here so I can separate them out. Pythagorean theorem. I'd like you to type me a number 1 to 5. 1 means like, I don't get this, I've never seen this before. 5 means I'm the master of this. This is super easy for me. Throw me a number in the chat about where you're feeling right now, and that'll give me an idea about when and how we might need to revisit that. And it's okay for something to be a bit of a struggle or something you're not quite sure I don't remember or I need more practice. Those are all, you know, smart students know when they need to practice something. Nobody's good at something the first time they try it, and so you may need a little bit more brushing up on this. Okay, thank you for that. Okay, let's jump in on our next trigonometry stuff. So if we've got a right angle triangle, and this only works with right angle triangles that have that 90-degree angle in them, there are some special names that we give to ratios in that triangle. Basically what that means is when we divide 2 sides of the triangle, one side divided by the other, we get a number. And that number we call a ratio because we're dividing one thing by the other. And so in doing math, to try and be able to talk about these ratios, mathematicians have come up with special names for these things. And when they make those special names, they're not usually thinking about high school students hundreds of years in the future, unfortunately. So These things get funny names. But we get three of them. We get sine, cosine, and tangent. And sine, cosine, and tangent just mean ratios of angles. They just mean we're dividing two particular sides. So you'll remember from last year, I hope, that whenever you see the word sine and then an angle, in this case it's angle A, in this triangle that's that angle right here, all this means is, hey, take the opposite side of the triangle, that's right here, and take the hypotenuse side of the triangle, that's right here, and divide those two. That's all that means. And of course, to remember that, we write the words SOH, so. And that means when you hear the word sine, that means you're dividing the opposite and hypotenuse sides. Same deal for cosine. That's just a funny word that someone came up with to mean divide the adjacent side by the hypotenuse. The adjacent side, of course, is the one that's actually touching the angle, right here. We'd call that lowercase b, that side. So that side is actually touching the angle, therefore it's the adjacent side. Even students who find themselves to be really good at trig mix those two up, adjacent and opposite, a lot. So you just got to be really prepared to try and catch that. Finally, our last one got named tangent, and tangent just means that you're going to take the opposite side and you're going to divide it by the adjacent side. So we end up with SOHCAHTOA. That's kind of our shortcut to remember trigonometry. You've probably seen that before in grade 10. SOHCAHTOA is our short form that reminds us, what do we do with sine, what do we do with cosine, what do we do with tangent. Dasha, your cat's name is cotangent. That's awesome. We're going to get into cotangent later in the period. Hilarious and very math teacher approved. So we just need to remember what these ratios mean, right? You can actually print off a table, and I'll probably end up posting it on this lesson because some students really like it. You can print yourself off a table that has 3 columns, one for sine, one for cosine, one for tangent, and it's got all the angles 0 to 90 degrees, all the acute angles 0 to 90 degrees. And it gives you all of the ratios. They're right there on the table, all of them. But when you use a calculator, it can do it a little bit more precisely, and it just stores them in the calculator so you don't have to look it up on a table each time. But before people had calculators, they just used it like a table, where it would be written out on a sheet of paper in a nice organized little table, and that's what you would use for your trigonometry. We're going to use our calculators, of course. So now is as good a time as any. Why don't you please just make sure you've got your scientific calculator with you. Most of you will be using probably just the same one you had in school before. I'm going to be using, if you can see the video of my face, I like to use a graphing calculator. I'm fine if you want to use one like that. If you want to use one on the computer, they are not great. The one that's a default on your phone is terrible. So both Android and iPhones, their default scientific calculator, when you turn your phone sideways, is total garbage. It makes it really hard to type stuff in and keep it in order. You can't just type in one big long line really easily without using tons of brackets. They're a total pain. So I think it's really important that you have a good and decent real calculator, and you're not trying to type it in on a screen. That'll make your life a lot easier. As questions come up, feel free to just throw them in the chat. You can unmute and speak, or throw up your hand if you want to do that. But if you just want to throw it in the chat because you don't want your voice to be heard on the video, that's fine too. Okay, so what we're going to do is we're going to try this basic calculator skill. And it's really important that you're able to do this. So what we're going to do is on our calculator, we're going to type in sine of 31 degrees and cosine of 70 degrees and see what we get. So I'd like you to try that right now. You're going to need to make sure your calculator is not in radians mode. If it's in radians mode instead of degrees mode, you're going to get all of these answers wrong. On some calculators, you'll need to type in the number of degrees first. So for example, you'd type in 31 and then you'd go sine. In some calculators, the better ones, you type in sine and then 31. So I'd like you to try that right now. You should be getting these answers that you see here. If you're not getting those answers, then that means that your calculator is probably in radians mode or that you're not using it correctly. An easy way to tell if you're in radian mode on most normal scientific calculators is it has an R, like a capital R, somewhere on the screen. So look for that. If there's a capital D on the screen, that means degrees. If there's a capital R, that means radians. We want it to be in degrees, at least for now. For the 11U class, we will end up doing some stuff in radians later. But degrees is your standard one. It's much more common. Radians are mainly only used in like science and engineering. So we will touch on those for the 11U class. Cassie, yours has a capital M. A capital M. Can you show me what type of calculator you've got? Okay. It's a Casio, yeah? So what you'll probably have to do is the easiest way to do it, Marsha, yours is the same. I don't know what the M means, but it means it's in the wrong mode of some kind or another. So there is probably a button on there that says mode. You might try pushing that, but the most effective thing I've found is I just look up a YouTube video. I type in the name of the calculator, like if it's a Casio whatever, and then I type in put in degree mode. That's the easiest way to find it. Usually in class I can fiddle around with it and figure it out. It's going to be up to you in this case, or if you're really stuck you can tell me while we're doing our practice and I'll try and help you with that. But if you look up a video, type in your calculator name, put in degree mode, it should help you out. You can also look for that mode button and see if that will help you. Okay, to both Cassie and Marshy. Thanks for letting me know that is a problem. I've had students do their whole test in radian mode or a different mode before and get everything wrong, and then it's a mess, and I'll have to go through and look and see do they actually know what they're doing and they just had it in the wrong mode. Okay, now we're going to do calculating angles when we have a ratio. So that means we've divided two sides, we have some kind of decimal number from dividing those two sides, and we want to figure out what angle is in that triangle. So what we're going to do is we're going to do our inverse. So you'll see on the screen it says use a calculator to determine theta, that's our usual symbol for angles of course, to the nearest degree. So we're going to round off to the nearest degree. Okay, I'm going to scroll down one spot here because I want you to see how I like to have that written. If it's written like this, this shows me that you really understand what you're doing. So in our first one it says cosine of some angle theta, we don't know what it is, gives us 0.3312. That means cosine is adjacent over hypotenuse. That means in a triangle, I divided the adjacent side by the hypotenuse side. I got this weird decimal number. What angle do I have in that triangle? So I'm going to use my inverse cosine button. So that means on your calculator, you're going to need to look for, usually you've got 3 buttons, and they say sine, cos, and tan. This is how most of them look. And then above the buttons, it'll usually say this. Sine inverse, cos inverse, oops, tan inverse. It's got that little -1 symbol. So usually what you'll need to do is press your button up here in the left that says like second, something like that, or it might say shift. And then you'll need to press sine, cos, or tan, and that'll do your sine inverse, and your tan inverse, and your cos inverse. Okay, so I want you to try these and see if you can get to those angles. So the answers are on there. They're rounded to the nearest degree. But I want you to try these and make sure you can get there. Okay? That'll show you that you're punching these in the correct way. For some of you, it's been a year since you've done this. So you're probably pretty rusty. For some of you, you did this in that learn from home period, so your understanding of this might be kind of shaky. For some of you, you'll feel really sharp on this stuff. So we've got a really broad skill set in this class based on the circumstances of the, the past year, how long it's been, or if you were in that second semester last year. Oh, someone has their hand up. Thanks, thanks, Jillian, for letting me know. Emma, go for it. Yeah, that'll be fine. Does it have a sine, cosine, tan button on it? Oh yeah, that'll be fine. That one's awesome. So just make sure, practice with it so you are sure you know what you're doing. If it's got, some of them have a degree button on them, but just be cautious about how you use it. Make sure you know how it works, okay? But if it works for you, super thumbs up. Good question. Okay, I'd like you please to throw in the chat for me, and I'm going to type it in here so I can just do a quick check on it later to help support those people. I'm going to say using sine, cos, tan buttons on calculator to find angles and ratios. So what we just did on this page, I'd like you to type into the chat again out of 5. A 1 being like, I can't do this at all, I don't remember this at all. A 5 is, yep, got it, no problem, remember it perfectly, easy stuff, calculators work doing exactly what I want it to do. Again, no problem if you're a 1 or a 2, that's totally fine. That just means that we need to pinpoint, maybe you've got some calculator issues, maybe you need just a little extra practice, right? So be honest with me, let me know, and I'll give you a hand. Okay, so Dasha, you haven't done this before on a calculator, so that's good to know. You and I might need to work on this a little bit more, or maybe we'll get a small group to practice this if you haven't done it this way before in a calculator. Okay? Thank you for the heads up on that. Okay, so this is how we transfer from an angle to a ratio, where we're dividing two sides, or a ratio, turn it into an angle. That's how we go back and forth using our calculator. So I want to actually do that now. I'm going to do one, and then I'll have you do one. If you just want to jump in and go for it, I want to encourage you to do that. That's totally fine. But I want to move kind of slow just to make sure we're all on the same page here. I'm going to do a calculation where I'm going to determine the indicated side. So that would be this one x right here. I'm going to try and find out that side. So the very first thing I'm going to do is I'm going to remind myself that I need to use SOHCAHTOA and figure out which of these trigonometry ratios I'm going to use. Am I going to be dealing with the opposite and hypotenuse sides, the adjacent and hypotenuse sides, or the opposite and adjacent sides? That will tell me which trigonometric ratio I'm supposed to use. So I want to know this side. I already know this side, and I know this angle. I could find this other angle over here because I know in each triangle there's 180 degrees, so I could find that angle that I don't currently know, but I think I probably don't need to do that. So let's have a look and label these sides. That'll help me. This is the angle I'm looking from, 72 degrees. The side that's touching that angle, that's not the hypotenuse, is my adjacent side. So I'll put an A right there for adjacent. The longest side that's across from that 90-degree angle is my hypotenuse, so I'll put an H there. And the side that's directly across from my angle is my opposite side. So I'll put an O there. So I need to decide which are the important pieces of information here. I need to know what I have and what I want. Well, I notice that I have the hypotenuse. So I'm probably going to be using something that has hypotenuse in it. That probably means sine or cosine, because they both have hypotenuse in them. The opposite side is the one that I want. So that's important. So I probably am using one of the ones that has the opposite side in it. So you'll notice I put a little dot over opposite. The adjacent side, I don't know it and I don't need to know it. So I'm just going to kind of not worry about the adjacent side because I don't know it, I don't need to know it. Now let's have a look. Sine is the one that has both the hypotenuse and the opposite side in there. Great. So that's the one I want to use. So to do that, I'm going to say sine of my angle. My angle is 72 degrees. And I remember that sine means opposite divided by hypotenuse. That's right up here as well, right? So my opposite side is the one I don't know, that's x. And my hypotenuse side is 36. Most common mistakes in basic trig is students mixing that up. So just go slowly and carefully. So that's the big step. I've set up my ratio. Now I need to get x by itself. Right now it's being divided by 36, so to get x by itself, I'm going to actually multiply both sides by 36. So I'll multiply this side by 36, and I'll multiply this side by 36. When I multiply my right side by 36, oh, that's 36 divided by 36, it goes away. That's convenient. And so I'm just left with an x on this side, and on the other side I've got 36 times sine of 72. Now we're going to need our calculator because we need to know what the sine of 72 is. When you write this, just write it to 4 decimal places. It might come out to like 1 billion decimal places. I only want it to 4. So 4 decimal places is good. So on my calculator, I'm going to go sine of 72. I'm going to really hope I'm in degrees here. I am. And I'm going to round that off to 4 decimal places. So it's telling me 0.951, and if I round off the last place, 1 times 36. Now ideally I've just left that big decimal in my calculator so I can just go times 36 and get my answer. If I don't tell you otherwise, ratios go to 4 decimal places, degrees to the nearest degree, and sides go to 1 decimal place. I don't mind if you mix that up for now, but that's generally how I'd like you to do that. So it looks like that side we didn't know was 34.2 units long, whatever that is. So please make sure you can just plug those in and get there. If you're comfortable with that, what I'd like you to do is jump to this next one. And on your page, I'd like you to give this next one a try. This time you're finding the hypotenuse. The algebra involved with this one is a little trickier. So I'll go through it quick, but I'd just like you to try it if you haven't had a chance to look at that yet. Emmy, that's totally fine. So you're just typing in 36 sine 72. What your calculator is doing is it's recognizing that that 72 is right next to the sine, so that's 1 unit, and then it's recognizing that it's multiplying the 2. So as long as you've tried it and you've proved that your calculator works that way, go for it. Good calculators will do order of operations for you. That's why I really don't like cell phone calculators, because they don't assume that, which is a real pain. So yes, you should be good to go. Yep, looks good. So your calculator is doing order of operations for you. Now you said, so you're skipping the typing in like the ratio. I'm totally fine with that. No problem. While we're working on this stuff, because again, we are trying to like lay a good foundation, and it's hard for me to check my pacing to know where you're at when I'm not in the same room as you. If you're one of those people who on a particular thing, like maybe Trig, you're really experienced, and you're like, yeah, this is moving slow, I get this. Remember, you can flip over to Edsby, have a look at the work that I've assigned for the day, and you can start looking at that and poking away at that. So I don't mind if you're like managing your own learning a little bit, if you're feeling like things are moving slow. But I do want to make sure we got a good foundation in this for everybody. So feel free to skip ahead a little bit if you feel like things are moving a bit slow. Okay, I'm going to move this around a little bit so I can jump in on this next one. So my next question here is going to allow us to find the hypotenuse. So I know you've had a chance to pick away at this, so I'm going to go kind of quick. Let's do this one in green. Here's my side, or my angle rather. That means this is my opposite side, this is my hypotenuse, this is my adjacent. So it's actually the same as the last one we did. If I go SOHCAHTOA, I notice that I want the hypotenuse, so that's probably important, and I have the adjacent side. So that means cosine's the one I want, because it's got both adjacent and hypotenuse in it. So let's set up a ratio. We're going to go cosine of 40 degrees equals, my adjacent side is 48, my hypotenuse is x. Now we need to solve for x. That means we need to have it on the numerator. Right now it's on the bottom, it's on the denominator. You might have heard the term in grade 10, just cross multiply. And that's fine. If that works for you, that's good. I find that doesn't really describe what you're doing with the math, so I want to describe it a little differently. I'm going to multiply both sides by x. That's going to get rid of it on the right and have it up over here on the left. So I'm going to end up with x cosine of 40 equals 48. And now I'm going to divide both sides by cos of 40. So if I divide both sides by cos of 40, it disappears here on the left, and it ends up under here on the right. So if you like the cross multiplying thing, that's fine. You can go for that, no problem. But what I wanted to do was multiply both sides by x, so it moved up here, divide both sides by cos 40, so that moves down here. Another really common, easy mistake for students to make is when they're doing this sort of problem and they're rearranging the stuff, they rearrange it improperly and they end up with the 48 and the cos 40 on the same line, like both on the numerator on the top. So, got to be a little careful of that. Cos of 40, I don't know what that is, but I'm going to find out. Cos of 40 is 0.7660. Again, if you just like leaving it as the as cos of 40 when you type it in your calculator, I got no problem with that. So 48 divided by 0.7664. This looks like 62.7. So those are basically the two ways you'll have to find a side of a triangle. I'm going to put something else here in the chat. Side of a triangle. I'd like you to give me a 1 to 5 on finding the side of a triangle. So what we just did, how do you feel about that? If I gave you a brand new side of a triangle problem, Would you say I'm a 1? I don't have any idea how to do it. I don't even know where to start. That's okay if that's you. Or am I a 5? Okay, awesome. Thanks, everybody. And thanks, Marcy, for that advice to Cassie. Cassie, I'm not sure if you saw that, but look in the chat. Marcy had some advice on fixing the issue with that calculator. So thanks for helping one another out. That's great. Okay. So it looks like we are 3s, 4s, and 5s. Mostly 3s and 4s. So that's good. That means we're pretty solid, but we need some practice. Cool. Just where I was hoping we'd be. Okay, let's move on to the other kind. This one we're going to be finding an angle. So we're not finding a side anymore, we're finding an angle. To do that, we need at least 2 of the sides. And we have 2 of the sides in both of these, which is great. So let's jump in and give that a try. On my first one, I'm going to label this really quick. So I'll do one and then I'll have you do one, same as before. But if you're feeling good about it, go ahead and jump straight in. So my angle here is angle A. I kind of think about that's where I'm looking from, right? So the adjacent side is the one that's touching angle A. I see it's actually is one of the 2 sides that make up angle A. The hypotenuse is the largest side that's across from that 90-degree angle. And the opposite side is all the way over here on the other side from A. So I'm going to do my SOHCAHTOA thing. And I do this at the start of every trig problem because I find it keeps me from making mistakes. Looks to me like the hypotenuse, I don't know it, and I don't want to know it. I don't need to know it. So that probably means I'm going to be using tangent because it doesn't have hypotenuse in it. But let's check. Opposite and adjacent are the sides I want. That one has opposite and that one has opposite. That one has adjacent and that one has adjacent. Yeah, so tangent is the one I want. Quick little tip. If you're not dealing with the hypotenuse at all, it's a tangent problem. One of the things we won't get to do, but I often would do with math classes, is we'd go out and measure the height of the school flagpole just using a protractor because you can't climb up the flagpole terribly safely. I am going to, in a couple of days, post some videos of water bottle rockets, and we're going to use those. Something I got into with my son this summer is you use water pressure rockets using a bike pump and water bottles, and we'll do some height calculations using Trig. I wish I could do it with you in person, maybe next time, but we'll try some height calculations like that. Okay, so we're going to use tangent. So I'm going to say tangent. Let's go back to blue actually. So we're going to say tangent. But what's the angle? Oh, the angle is A. I don't know the angle. That's what I want to find out. So tangent of angle A. And now I'm going to say tangent up here tells me opposite over adjacent. So the opposite side is 4, and the adjacent is 8. So I can divide 4 by 8. Let's just do that. So we'll say tangent of A equals 4 divided by 8 is 0.5. So that's my ratio. It's not to 4 decimal places because this one happens to be exact. So how do we find an angle? Well, we say we got to use our inverse button on our calculator. So I'm looking for that tan inverse, and I'd like you to write it like this, right? Tangent inverse of 0.5. So on your calculator, let's try that out right now. I'd like you to make sure you can get the same one as me. So I'm going to hit my second function, my tangent inverse button. I'm going to type in 0.5, and I'm going to round it off to the nearest degree. Looks to me like it's 27 degrees. So I'd like you please to make sure you can get 27 on your calculator. That way you'll know you're punching it in correctly. Okay, I'd like you to give this next one a try. It's very similar, but you might not be using tangent ratio because I noticed there's a hypotenuse side in there. So that probably means you're using one of the other ratios. So let's go for it right now. On your paper in front of you, give that one a try. When you've had a chance to finish that one or get as far as you can and get stuck, can you give me a wave, please? Okay, I'm going to dive in on this one. If you're still going at it, keep it up. Great job. I see my angle A is up here at the top, so I'm going to label this as my opposite, this is my adjacent, and this is my hypotenuse. I notice that my hypotenuse side is one of the ones I have, and my opposite side is also involved. So it looks like this is going to be sine. So I'll go sine of angle A is my opposite, which is 10, over my hypotenuse, which is 13. When I divide 10 by 13, I get 0.7692. And so now I need to use my inverse button on my calculator. And 50 degrees is my nearest degree. Okay, so that's our basic trig skill set. Pythagorean theorem. Able to get a ratio when we have an angle. Able to get an angle when we have a ratio. Able to look at a triangle and calculate a side. Able to look at a triangle and calculate an angle. That's our basic trig toolkit that we've covered. So I'm going to have us, just before our break, we're going to, I'm going to say find an angle. And I'm going to ask you to give me one more 1 to 5 based on how you're feeling about finding an angle, this page that we just did. Okay. Thank you, everybody. Looks like someone accidentally hit their share screen button, which you can do now because I want you to be able to share whiteboards eventually, but just please be careful of that button, okay? Because if you hit that one accidentally, it will share your screen. Okay, everybody, let's take a break. We've been going for a full hour, and you've been very patient, sitting there working along and following along with me. Let's take until 12 minutes after 2. So that's 2:12 sharp. I'll see you back here. Thanks, folks.